This is 2.5 dilations, parts 1 and 2. A dilation is a transformation in which a figure is made larger or smaller with respect to a point. That point is called the center of dilation. We are going to determine whether the orange is a dilation of the teal. And looking at these two squares, I can see the teal is smaller than the orange, and if I connect corresponding vertices, I see that they will meet at this point. That point is the center of dilation. In looking at these two triangles, I can see they're the same size, and if I connect their corresponding vertices, these lines will never meet because they are parallel, and the triangles have the same size and shape, so this is not a dilation, but it is a translation. The scale factor is the value of the ratios of the corresponding side lengths of the image and the original. So the scale factor shows how many times larger or smaller the image is. To dilate a figure in the coordinate plane with respect to the origin, we're going to multiply each of the coordinates of the vertexes by the scale factor. So my original point, x gets multiplied by k and y gets multiplied by k. If k is larger than 1, the image will be larger, and we call that an enlargement. If k is less than 1, the dilation will be a reduction, and so the image will be smaller. The vertices of a triangle are given here as A, B, and C. We're going to draw the image after a dilation with a scale factor of 3 and identify the type of dilation. So I'm going to take my points as given. The scale factor is 3, so the x and the y get multiplied by 3, and so my new point, A prime, is 3, 9. For B, each x and y get multiplied by 3 to get B prime is 6, 9, and for C, each multiplied by 3 makes C prime 6, 3. So if I plot the original and the image, I can see that it starts out kind of small and it gets larger, so this is an enlargement. The vertices of a rectangle are given as A, B, C, and D. We're going to draw the image after a dilation with a scale factor of 0.5. Then we're going to identify the type of dilation. So to get these points, I take my originals here, and each x and each y get multiplied by a half. So my originals will be multiplied by half to make the primes, which are going to be half the size of the original. So I'm going to plot the original and the image, and we're going to see. The original is in blue here, and the image is in orange, and I can see that it got smaller, so this is a reduction. And finally, the vertices of a trapezoid are given as A, B, C, and D. We're going to dilate the trapezoid using a scale factor of 2, then translate it 6 units right and 2 units up. What are the coordinates of the image? So to take the original and to use the scale factor of 2, each x and each y gets multiplied by 2 to make the primes. In plotting those, so I can see what's going on, I have the blue is the original, orange is the prime, and then I take that prime and I'm going to go 6 units right, so that's adding 6 to the x, and 2 units up is adding 2 to the y coordinates. So that takes this orange one and scoots it 6 units right, 2 units up. And I end with prime prime here. So A double prime and so on. These are the answer.